Okay, here's the answer key to the logarithms test for your test correction purposes. Number one, Susie invests $500 in an account that is compounded continuously at an annual interest rate of 5%. So right away I write down P, principal is $500. We know the interest rate is 0.05 because we have to move the decimal place over to the left 2 places. T is the time in years. Approximately how many years will it take for Susie's money to double? So how many years? Well, that means T is question mark. And we know that Susie's money will double, and that's A, which is the amount after it doubles, which is going to be 500 times 2, which is 1,000. So we plug all these givens into the equation that they provide to us, knowing that we want to isolate the exponential expression. So we divide both sides by 500, take the ln of both sides because it's base E. The ln of E cancels out, the 0.05t comes down. We divide both sides by 0.05, and ln of 2 divided by 0.05 is 13.86. Number 2, they give you the formula. They want to know the value of the car after T years. C is the original cost and R is the rate of depreciation. If a car's cost when new is $15,000, the rate of depreciation is 30% and the value of the car is now $3,000. How old is the car to the nearest tenth of a year? Well, again, they want to know what T is, the time. We know that the car has depreciated from 15,000, which is C, down to 3,000, which is V. 30%, move the decimal place 2 places over to the left, is 0.3. We plug all this into the equation, into the formula, dividing both sides by 15,000, we end up with 0.2 equals 1 minus 0.3 to the T power. 1 minus 0.3 is 0.7. We can just simplify as we go. And we are not going to use ln, we're going to use log because there's no base E. We're going to use log because the T is what we're solving for. We want to bring this down from the superscript down here to the regular equation. And finally, we divide both sides by log of 0.7, giving us 4.5 years. Number 3, we have to rewrite 16 and 64 with common bases. So I used 2 to the 4th power and 2 to the 6th power. You can eliminate the 2's, and then we distribute to get 8x plus 12 equals 6x plus 12. Subtract 12 from both sides, subtract 6x, and we get 2x equals 0 divided by 2, x equals 0. In the check step, we end up with 16 cubed equals 64 squared, which does check out. Number 4, the number of bacteria present in a petri dish can be modeled by the function n equals 50 e to the 3t power, where n is the number of bacteria present in the petri dish after t hours. Using this model, determine to the nearest hundredth the number of hours it will take for n to reach 30,700. So again, we want to find out how much time has passed for 50 bacteria to multiply to 30,700. This is like an outbreak. Dividing both sides by 50, we end up with ln of E. We take the ln of both sides, right, because this is the E exponential with base E. So the 3t comes down, the ln of E cancels out. We divide both sides by 3, and very carefully we put this in the calculator. And remember to close your parentheses before dividing by 3. So we put this in the calculator, it's ln of 614. Close your parentheses, then divide by 3. If you don't close your parentheses, you're going to get a wrong answer here. So the answer is 2.14 hours. Number 5, this is solving a logarithm equation. So we want to go around the world to rewrite it as an exponential. And 27 to the 4/3 power is 81. But like I showed you, you can also put this in the calculator. 27 to the parentheses, 4 divided by 3, close parentheses, will give you 81. Make sure you put this in parentheses. And then we have 81 equals 2x minus 1, so we add 1 to both sides. We get 82 equals 2x dividing by 2, and this is pretty straightforward, easy algebra. The answer is 41. Number 6, we want to expand log of 4m squared, so we use the product property to rewrite it as an addition, log of 4 plus log of m squared. And then the power property is bringing the 2 down to the front as a coefficient. The answer is 3. Number 7. So what you could do here, well, obviously you could plug this in your calculator and make sure you plot the points. What you could also do without the calculator, you could just create a table and choose a few x values that are on the negative end and a few x values on the positive end, and don't forget x equals 0 at the origin. Okay, so then we get these y values, and we take the order pairs and we plot them. Okay. Remember that the asymptote is a line that the graph approaches but never reaches. This, ladies and gentlemen, is the asymptote. You see how the graph curves down and it gets really, really close to the x-axis but never actually reaches it. And the equation of the line x-axis is actually y equals 0. So the answer, the equation of the asymptote, is that right there, y equals 0. Number 8. So here we want to, the expression log base 2 of x minus 4 is undefined for all values of x, such that, well, remember, you cannot take the log of 0 or a negative number. So we know that this expression will be undefined whenever x minus 4 is less than or equal to 0. So we write ourselves an inequality, and the easiest way to do this is just to solve the inequality. Add 4 to both sides, and x is less than or equal to 4. The answer is 3. Now, if you want to, you can plug this in the calculator, and you can just look at the table and see where it says error, right? It's going to say error down here for all of these because you cannot take the log of 0 or a negative number. Okay, you can also just, without a calculator, just sort of use your common sense and plug in values, and you can see that, you know, here's positive 1, it's defined, but if it's if the object, if the expression that you're trying to take a log of is 0 or negative, it's undefined. Number 9, here we are condensing this logarithmic expression using properties. First thing we're going to do is we're going to use the power property. So we have log m to the 1/3 power minus log n squared. Then we're going to rewrite the fractional exponent as a radical, which is cube root of m. And then we're going to use the quotient rule to take this minus sign and make it into the fraction bar. So the final expression is log of cube root of m over n squared. Number 10, remember, your calculator does not have a log base 2 button, but it does have a log base 10 button. So you're going to use the change of base formula, which is the log of 22 over the log of 2. Remember, it's the log of the number that you're taking the log of divided by the log of the base. So plug this in the calculator, and you end up with 4.46. Now here, you need to isolate the logarithmic expression first. So we want to multiply both sides by 2. That gives us log base 10 of x plus 2 equals 4. We go around the world. We get 10 to the 4th power equals x plus 2. 10 to the 4th power is 10,000, and we solve this one-step equation, subtracting 2 from both sides, and the answer is 9,998. Number 12, we want to solve this logarithmic equation by using the properties of logarithms. We want to condense this first by using the product rule, product properties. So we want to multiply 2x plus 3 and x plus 5. We want to, as you can see, I wrote it as a product. And what I did was, here we go, I went around the world first, around the world. So basically, x plus 3 squared equals 2x plus 3 times x plus 5. We need to FOIL twice. After we FOIL twice, we end up with this expression, right? This equation, right? We want to combine like terms and subtract terms, so we end up with 0 on one side and everything else on the other side. So here we have x squared plus 7x plus 6, and we factor x plus 6, x plus 1, set them both equal to 0, and our solution set is -6, -1. Now don't forget, ladies and gentlemen, to plug back in to do your check step. As you can see, when we plug -6 back in, we end up with taking the log of a negative number. You cannot do that, so we must reject -6. -1 is acceptable because when you plug -1 in here, you end up with 2 times -1 is -2 plus 3 is +1, and -1 plus 5 is +4. So they're both positive. You can take the log of positive expressions. There you go. Oh, the extra credit. So this right here, Kristen invests $5,000 in a bank. Principal is $5,000. The bank pays 6% interest compounded monthly. N is 12 because monthly means 12 times a year. 6% is the interest, so we move it 2 decimal places to the left to get 0.06. How long must she leave the money in the bank for it to double? How long must she leave the money in the bank? That's time, and that's the question mark. The $5,000 will double to 10,000, so 10,000 is A. Plugging all this into our formula, we want to isolate this entire exponential part of the expression. So we divide those sides by 5,000. We get 2 equals 1 plus 0.06 over 12 to the 12t power. Let's simplify by calculating 1 plus 0.06 divided by 12, which is 1.005. We now take the log of both sides, so the 12t can come down. And as you can see, we're going to divide both sides by 12, and log of 1.005, that cancels those out, getting the t by itself. And so we carefully put in the calculator log of 2, here, let me write it out, log of 2 divided by parentheses 12 log of 1.005, close parentheses, then close parentheses again for this right here. You get 11.6 years. And there you have it. Best of luck to you with test corrections.